Hello, welcome back again. I hope you are enjoying the lecture so far. Here is the content of the lecture. In the previous lecture, Extracting Moodle Data, we have learned how to extract Moodle data for social network analysis. In this lecture, we'll perform social network analysis on a dummy Moodle data. We'll perform the following. First, we'll read dummy Moodle data, then process the data for creating social network analysis and a graph. Then we'll analyze and calculate centrality measures. In the end, we'll export the centrality scores to an Excel.
Here is the dummy Moodle data. As you can see in the first column, there's a course ID, then course full name, and what is the discussion is all about. Then the post individual ID, sender ID, and the sender name and receiver ID and receiver name, and the parent ID of the post. Uh, we have extracted similar data in the video lecture, extracting Moodle data, and we'll now perform the social network analysis on this data itself. Now let's find a notebook. Here is a sample notebook. As explained in the content of the lecture, these are the steps we'll do. First, we need to read the dummy Moodle data, but before doing so, what we need to do, we need to upload the data. There are actually two ways of doing it. In one of the lectures, my colleague showed you how to mount the Moodle data. There is one way of doing it. Another way could be just upload the data in the session storage. So I will upload the data. Let me try to find so the data is now uploaded, and then the first step would be importing the necessary library. We'll be using standard Python, and we'll use pandas library, networkx for social network analysis, matplotlib for the visualization, and numpy. So let's import the libraries. Then we'll read the Excel files what we have uploaded in our session storage. Okay, it seems like there seems to be some error, and what could be the error is. So let's try to understand what the error says. It says no such file or directory, half density data. So as you can see, I have the wrong name. So once I'm done uploading the data, I need to adjust the file path and name so that it present the data what I have uploaded. So let's edit it. Dummy underscore data SNA underscore analysis. Let's try again. And we have successfully read the data. So let's see what's the next step. Next, we need to process the data to create the social network analysis. So first, we will create a list of unique sender and receiver. And as you can see, even though in the dummy data, these are not real person, but when you're exporting your Moodle data from your Moodle, it is strongly recommended to anonymize the data so that you comply with the GDPR and other data privacy law. So we'll anonymize the data where each of the real name will have this kind of prefix student and followed by incremental numbers like student 1, student 2, and go on. So let's do so. As you can see, now the real names are being anonymized with student 1 and followed by similar. Then we will get rid of not needed columns. So now we have this kind of format, sender and the receiver. Then we'll remove the rows if there are any duplicates or null values. So now we removed the null values, and then we have this kind of source and targets. Next, we'll create a graph from the edge list from the data what we have created. So basically we will read the same data frame what we have created in the previous cell block called output underscore df, and we'll create a visualization, and in this visualization we'll use this Kamada Kawaii layout, and we'll be using this networkx library. So let's do so. And here is our network graph. As you can see, it shows the interaction in between the students, and we can also see that there were some students who were replying to themselves. So they have this kind of own feedback loop, let's say. And what I have mentioned earlier, that the graph has been drawn using this Kamada Kawai layout, which arranges the nodes in a way that attempts to minimize the number of crossing edge and distributes the node evenly. This layout is based on a spring-like force model where nodes repel each other while edges act like springs holding the connected nodes together. The intention is to visualize unfold the graph in a manner that clearly reveals its structure. In the generated graph, as you can see, the node representing individuals in the social network, meaning individual students, are colored gold. Edges representing the interaction or connection between the individuals, in this case, when the students replied to another's, are colored red. Arrows indicate the direction of the relationship, as this is a directed graph. And labels display the names of the individuals associated with each node. Student 51, student 49, student 46, and go on. However, it is better to remember that if the graph is dense and there are like so many overlapping labels, it may become quite difficult and challenging to explain the individual nodes and their connections. And this is a common issue when visualizing complex networks with many nodes and edges. And that's why we need to employ further measures so that we can calculate some individual scores and we can identify how each student performed. And in order to do so, we'll use the centrality measures. But before doing that, we'll plot another graph following this kind of circular layout. So here is a circular layout, and I think it shows the interaction more clearly because you can see more in a more clear picture when there is a own feedback loop and who is contacting with whom. In the next, we'll perform the centrality measures to evaluate students' performance in the discussion forum. I'm not gonna go through into details of this. This notebook will be shared with you, and you can read it through in your own time to understand what centrality measures mean in the context of the discussion forum. In a higher level, when there's a degree centrality, it means that how the student is connected to each other. A student with a high degree centrality are likely more participating in the discussion, posting frequently, and engaging with many peers. Where the closeness centrality implies that a student is relatively close to other students in the terms of the shortest path length. That means how quickly the student can interact with the other student in the forum. Betweenness centrality represent that how a student is connected to a different group of students, and a student with high betweenness centrality act as a bridge or intermediate connection to communicate in various discussions in the thread. For instance, if I post something and you post something and then someone reply on that post, that means that you are acting as a bridge in between my thread. And the eigenvector centrality represents that how a student is well connected or not well connected to the central students. So if someone is connected to the influential peers, meaning having high eigenvector centrality, that means that they have indirect influence on the forum's dynamics through their connection with the influential students. And if we want to transfer these measures to more understandable format so that we can explain the students' performance, for instance, active contributors. So students with high degree centrality are more likely active contributors in the discussion forum. They post frequently, answer questions, engage in discussions. Their active participation can positively impact their performance by demonstrating their knowledge and engagement. Effective communicators are students with high closeness centrality. They can quickly exchange information and ideas with their peers. Effective communication can enhance their learning performance and experience. Community builders are having with high betweenness centrality and act as community builders. They facilitate interaction between students from different groups, creating a sense of unity within forums. This role can contribute to a positive forum atmosphere and collaboration. And I think when we have tutors in our discussion forum, it is also better to act in a way that tutors have high betweenness centrality. And if we want to evaluate the performance of the tutors, we can always identify node who represent the tutors and can see that whether they have high betweenness centrality, that means that have they performed well in the lecture or in the course so that they facilitate a discussion among different students. Well-connected learners. Students with high eigenvector centrality are well connected to other influential learners. They may have access to valuable resources and insights shared by influential peers, which can enhance their own performing and learning. In summary, the centrality measures provide a holistic view of students' participation and influence within the discussion forum. High centrality can indicate active, well-connected, and influential students who are likely to perform well in the forum. However, it is essential to consider both the quantity and quality of contribution to assess students' actual performance and engagement in the discussion. Uh, in the scope of the lecture, we are focusing more on the quantity so that we can understand the dynamics of the students in the discussion forum and explain their performance using social network analysis to be more precise using the centrality measures and export the results. So in the next code block, we'll calculate the centrality measures of the students, identify top 5 students and export the results of this centrality scores of all the students in Excel file so that the teachers can use the Excel file further to grade the students. So let's run this cell block. So as you can see, we have the top 5 students with highest degree of centrality and others. This is ranked on the basis of high degree of centrality, but we also have other centrality scores. And if we want to explain the results based on the theory of centrality measures, what we explained above in the context of students' performance in the discussion forum. So, as we can see, the student 34 has highest degree centrality, which indicates that student 34 is highly active and connected in the forum, engaging with large number of posts or peers. This level of engagement suggests a strong presence and active participation, which can positively impact their learning and contribute to their understanding of the discussion topics. Closeness centrality is 0.37, and they have the ability to quickly reach and interact with other students, facilitating effective communication and information exchange. Between the centrality, student 34 plays a significant role in bridging different sub-student groups, enhancing the flow of information and ideas across the forum. Based on the eigenvector centrality measures, it seems that they're also well connected to other influential and active students, which might afford them access to impart discussions and insights and further enhancing their learning. If we look to the next student, who ranked number 2 based on the degree centrality, it also indicates that they have their active participation and engagement with many students, and they also have the ability to quickly connect others, indicates effective communication skills. And they also have similar to student 34, student 61 acts as a connector among various group. They are also connected to the influential nodes, implying that they are part of key discussion and have access to valuable insights. If we also continue this analysis with student 10, it seems like that student 10 is less active than student 34, student 61, yet they have a good centrality score, meaning they're also positively impacting the discussion by their active participation. I'm not gonna go through the discussion for and the explanation for the rest of students. You will have this notebook and you can read it by yourselves. But it is good to remember that in summary, the centrality values provide specific metrics of each student's participation and influence in the discussion forum. Students with higher centrality values such as student 34 and 61 are more likely to perform well due to their active contribution and roles in connecting students. However, performance should be assessed based on quality and contribution and engagement in discussion. If we want to summarize the results of the centrality measures according to the provided terms which we have discussed earlier, like active contributors, effective communicators, community builders, and well-connected learners. So if you look in the active contributors, student 34 having a higher degree of centrality, it seems that student 34 is an active contributor, and frequently posting engaging discussions. This high degree of interaction demonstrates their significant involvement and contribution to the forum. Other notable active contributors are student 61 and student 10. Effective communicators. Student 61 possesses a high closeness centrality, meaning student 61 excels in effectively communicating within the forum. Their ability to quickly exchange information ideas with peers, enhancing their learning and learning of others. Student 10 also demonstrate effective communication skills. Community builders, based on the between centrality scores, student 34 and 61 act as a community builders, connecting different groups within the forum. Their roles in bridging various discussion promote unity, collaboration, and contributing significantly to forum's community atmosphere. Well-connected learners, as we can see that student 34 and student 10 have high eigenvector centrality scores. That means that their interaction with these peers provide them with access to valuable resources and insights which can considerably enhance their performance and learning. In summary, the centrality measures highlight the roles and characteristics of the students in the discussion forum. Students like student 34, student 61, student 10 exhibit traits of being active contributors, effective communicators, and community builders, and well-connected learners. These roles and characteristics are crucial in a discussion forum as they contribute to a vibrant, collaborative, and informative learning environment. Their engagement and connections not only enhance their learning experience but also positively impact the performance and the learning of their peers. Students with high eigenvector centrality benefit from connections with influential peers, enhancing their learning experience. So, in summary, uh, this kind of social network analysis with the graph itself and then having the centrality scores and explain the results in the more students performance term can can help the teachers to evaluate the students quantitatively rather than subconsciously or not following any numeric measures. And if the teachers want to give students grades based on the measures, for instance, teachers can choose the degree centrality, and let's say that if there is a score of 30% for all the students of the discussion forum for their engagement in the course, students teachers can take the degree centrality measure and multiply that with some multiplier and grade the students for their performance in the discussion forum, and they can do it with more insights from this using this social network analysis and centrality scores. Thank you.